I'm a principal analyst at IHS Markit, which is an analyst firm, working within our manufacturing technology group, really focusing on the area of smart manufacturing. When you think of smart manufacturing, you know, that many different words to explain the same thing. You know, there's a lot of initiatives out there today: Industrial Internet of Things, smart manufacturing, made in China 2025, Industry 4.0. Lots of these terms are out there in the market, and if you look at the Davos Summit in 2016, which is a gathering of world leaders, this was one of the key themes of the 2016 summit. So it's certainly an area that's getting a lot of headlines, but at the same time, there's a lot of confusion. You know, what is Industry 4.0? How is it different to Industry 3.0? Is there really any difference? Is this just hype from companies to sell some more product? And so the objective of the presentation today, I'd like to just take you through a little bit what it is, what are some of the technologies that are enabling it, and also what are some of the outcomes as a result of this. So when we talk about the fourth industrial revolution, we're talking about preceding industrial revolution, so I'll quickly give a little bit of history. So mid-1700s, we had what's coined the first industrial revolution. This was where we began to utilize water, utilize steam to power equipment. So this was the introduction of machinery. It first came in the textile industry, where you had people that were traditionally doing things like cotton winding, which was a very manual process. Through the utilization of water and steam, this then became mechanized. So we then had machines that were able to replace basic human tasks and functions. Now, this actually had a huge impact on productivity, so it was about a 500% increase in productivity. It also changed how products and where products were made. So we moved from small houses, looms, where looms were being produced, and this was centralized into cotton factories in a sense. So really with the first industrial revolution, we went to the point of having factories, so centralization of manufacturing. We then moved about a century later to the second industrial revolution. This is where we started to utilize electricity. And through this, there was the introduction of things like conveying lines, which opened the door for mass production. And certainly, Ford was a primary proponent of this, where with their Model T, where they really moved from small manual processes, having people producing multiple elements of the car, to having somebody working on one part of a production line, just working on one specific part of an overall process. And this is called the division of labor, people now focusing on individual parts of an overall production. As I say, automotive industry was very early mover in this side. We then moved about another 100 years later to what has been called the third industrial revolution, and really that's where we are today. We're talking about, with the introduction of more IT, computers becoming widespread, the introduction of electronics onto the factory floor, products like PLCs, programmable logic controllers, that were now replacing some of the elements of where people were previously being used. And so robotics is another key area. If you go to most large automotive facilities now, you'll see many of those big articulated robot arms, and these have become a central part of the automotive manufacturing process and have become very commonplace. So that was the third evolution. This really also empowered people. We started to replace people from just doing very repetitive tasks to having robots replace some of that, and upskilling some workers, so having workers more involved in things like coding and programming. And so here we are today, and we're looking at the fourth industrial revolution. And really, when we talk about the fourth industrial revolution, we're talking about the confluence of a number of technologies. We know about robotics. There's further advancements in robotics, things like collaborative robots, more intelligent robots. We have the advancements in in 3D printing or additive manufacturing as well. And also, there's a change coming in how data is used. So we have what's called the Internet of Things, big data analytics, and this is where we're now talking about collecting a lot of data and connecting lots of devices. Now, we're not just talking about connecting devices, we're talking machines connecting to machines, we're talking machines to connecting to people, we're even talking about machines potentially talking across enterprises, talking up to the cloud, for example. And what do we do with all this data? How do we utilize this data to really change what has been done, if you like, in Industry 4.0? Now, there's a lot of benefits in terms of, actually just jumping back, some of the benefits that can be introduced through the discussions around Industry 4.0. When Henry Ford released the Model T Ford car, he said, you can have this car in any color you want, as long as it's black. Now we're moving to mass customization. There's the opportunity, if you purchase yourself a Dodge Viper now, this car is available in over 1 million variants. You can select the color, you can select the wheel trim, you can select the interior. Increasingly, customers are becoming more demanding and wanting products tailored specifically to their needs. And this isn't just in the automotive industry. If you look at the pharmaceutical industry, we're now talking about batch size 1, and this is where pharmaceutical products are being designed for individual people, where it takes into consideration your body composition and your need for different nutrients or different medicines, and medicines being designed specifically for you. We're also talking about democratization of manufacturing. In previous iterations, there was a very high cost involved in getting involved in manufacturing. We're talking about investment, large capital investment in big machines. Now we're really talking, as we move to more of a digital focus, and we're talking about digitization or creating digital twins of physical products, whether that's systems. It now becomes a lot easier and a lot cheaper for people to come into the market. You can design your products using design and simulation tools. You can test them. If you need to produce something very quickly, you can do a prototype through something like 3D printing. And this is really bringing down the barriers to entry to new market. It's also changing localization. We obviously went through the sort of move of outsourcing. Let's move all production out. Let's move it to China. Let's move it to these low-cost countries. Now we're starting to see some of this come home. The costs of manufacturing are being replaced by, if you look at the cost of a robot now, in many cases this is cheaper than employing a person. The benefit being robots don't get sick, they don't take days off, they don't make mistakes. Customers, as I say, are becoming more discerning. There's a need for shorter lead times. People want things now. And so having manufacturing located closer to the end customer is becoming increasingly important as well. So lots of benefits. So why haven't we done Industry 4.0? Why hasn't everybody moved wholesale? What are some of the concerns that people have? So we did a survey recently, and this was more specifically around the area of analytics, so using the cloud, using edge analytics, connecting devices. And so we asked the question, why aren't you doing this at the moment? A number of different reasons, and there's a lot of, some very valid reasons. Some of the reasons given are really misconceptions, misunderstandings of perceived problems. So certainly lack of skilled personnel is a challenge. We're talking about workers changing. We're not just talking about workers just doing very manual operations. Now we're talking about workers integrating data in their processes, workers needing more of an awareness of what data is really doing and transforming data to information and insight. Probably the one with the most buzz is that of cybersecurity. So recently we heard about the WannaCry virus. Now this is a virus that was recently announced hit the Honda factory, so introduced downtime. Cybersecurity is a really big concern. No, people are saying, data will never go out of my four walls, over my dead body, it's not going to happen. A lot of people we speak to very wary about sharing data, about connecting their devices. In reality, certainly cybersecurity is a huge concern, both from the issues of someone potentially hacking into your system and introducing downtime, or conversely hacking in and taking sensitive data, customer data, process data that's very sensitive. At the same time, there's also a lot of misconceptions as well. A lot of people think just because I'm connected, therefore I'm vulnerable. When I'm not connected, if there's an air gap, I'm nice and safe. If you remember a few decades ago in the 80s, there was what's called the Stuxnet virus, and this hit an Iranian nuclear facility. This nuclear facility was not connected to the outside world. The virus got in, shut down the system, and the issue was human error, human introduction of these problems. And a lot of the people we speak to when we start talking about the cloud, and the cloud is one of the more revolutionary parts of the technology that are going to influence Industry 4.0, a lot of people say, I don't trust putting my data on a cloud. Now, that is really based on the assumption that where I'm storing my data is a lot safer than where the data would be stored on a remote cloud. And a good analogy to explain that might be, if I came down and I had a briefcase with €1 million and I gave it to one of you, in front of everybody, you want to make sure you don't lose that €1 million. What do you do with the money? Do you take it home because you've got an alarm system at home and stick it under your bed? No, probably not. You go to the bank, because the banks are the experts in providing security for your assets and also providing you access to your assets as well. In reality, it's very much the same with data. Data is an asset you need to have kept secure, but also data is an asset that you need to have access to regularly. And so this mindset, my data is safer at home, is often not the case. And certainly within the manufacturing industry, investment in cybersecurity is woefully short. Companies don't have sufficient investment in cybersecurity. Oftentimes you might have the person responsible for your IT, half their time they're operating a machine tool. These are not people that are qualified. There's not the investment in cybersecurity products. So certainly this is a misconception that we come across often, but really when considering the large cloud platform providers, these are the guys that are spending multi-millions in ensuring that data is kept safe. And if they get hacked, that's the end of it. That's a real challenge to their business. But the biggest challenge we came across is, you know what? There's no clear return on investment. It's a solution looking for a problem. The technologies we've got, they're doing what we need to do. It's all like, what's really different? This is just marketing speak. It's vendor pushed. And in reality, when we talk about the fourth industrial revolution, from a technology perspective, we are probably not talking about revolution, but we're talking about evolution. It's really the outcomes that can be achieved through some of these evolutions in technology that are going to be where the revolution really takes place. And there's a few places that manifests. So really looking, well, what is the difference between Industry 3.0 and 4.0? So I've listed a couple of points here. There are a number of others. Sensors. So there's been a lot of talk. Are we going to have pervasive sensing everywhere? Everything's going to have a sensor. In reality, no. But the difference is that sensors are now going to become more intelligent. We're seeing more embedded intelligence. We're also seeing more connectivity of these sensors. So before you have a sensor, maybe you have an engineer or maintenance staff collect some readings and off they go. Now, this data is being connected and collected. Sensors are now smarter, and sensors potentially are now being used to provide analytics services off the bat, sending data straight up to a cloud for analytics. As I mentioned, connectivity is not just the sensor that's being connected, it's all the field devices. We're talking now about sensors being placed on things like pumps, on motors, on generators, and having these connected. So we're now talking about devices being connected. We're talking about machine-to-machine connectivity. Again, not a new thing. But then we're talking about machines connecting across multiple facilities, giving people at an enterprise level better insight and visualization, not just how one product is performing or one machine, but how is their overall production performing. And even connecting across an entire supply chain. Increasingly, we're hearing issues around, in the food industry, it's called stalk to fork, from the very origin of a product through to its final delivery to the customer. Having visibility and having data shared across that entire supply chain to understand things like when a product's going to be delivered, what is the quality of the product, what are some of the components that were potentially at fault. Big data, again, we've had data historians. We've had things like SCADA systems, the supervisory control and data acquisition solutions. But what we're talking about now is a whole new level of data that's being collected. It's estimated that about 2% of data that is collected is currently used. So data a far larger volume of data is going to be needed. Now, in terms of big data, we speak to some people and they say, yeah, we do big data. I was like, what tool do you use? And they say, well, we use Microsoft Excel. That's probably the definition of what big data isn't. If you can do it on Excel, you're not doing big data. Really, we're talking about significantly larger volumes. We're talking about multiple megabytes connected regularly. So data is coming at larger volumes, but also at larger velocities, more data coming across more regularly. Some of the other implementations, we're talking about interfaces that are making it easier for the worker to translate this data to information and insight. That's talking about mobility on the factory floor, so having tablets and mobile phones that are now collecting data, workers being given insight into processes they should be conducting, seeing alarms early on where there are faults in a system, but also other technologies, things like augmented reality. There are a number of companies, Tetra Pak is an example, a large packaging machinery vendor. They've introduced augmented reality systems where you put the goggles on and either you have instructions on a manual that are preloaded, so it will tell you, pull this valve, press this button, much in the same way as you would have on your typical office printer. But that will be there, enabling the worker to work hands-free. In other cases, you have centers of expertise, and here you'll have an audio link as well. Now you have expertise that is able to support workers on the factory floor and give them direct guidance, share some of that tacit knowledge that they've acquired to the workers working on the factory floor. Robots are evolving. Again, I mentioned these big articulated arms that we have on many automotive facilities, these big robots. Now we're talking about evolutions in things like collaborative robots. These are robots that can safely work alongside people. But certainly even as further evolutions take place, we're seeing artificial intelligence, robots that can reprogram themselves to optimize how they're performing, robots that can repair each other as well. So again, further developments. Within 3D printing, now we're talking potentially about new ways of designing products. Subtractive manufacturing, you're kind of limited in the certain dimensions and geometries you can create a product. If you're building additively, now you can take out certain material, you can design certain products that were never able to be designed before. And an analogy of this is, you can't drill a curve, but you can print a curve. So different products can be designed than ever before. Some examples, I mentioned the sensor side. So recently we saw, about a year ago, a company called ABB, they introduced sensors for vibration monitoring on their motors. This was in volumes, this is fairly cheap, so we're talking about a €50 sensor now being placed on a motor, monitoring its vibration, and as it gets information that shows atypical results, so as vibrations increase, maybe this is an indication of a bearing failure or a misalignment of a bearing. And this they're now using to provide analytics, sending this data up to the cloud and offering services to their customer. And it's not just in motors, I mentioned pumps, generators, but also we're seeing it in mechanical components. I was speaking to a leading European manufacturer of mechanical components, and they were talking about some of the challenges they were facing, say, look, when we're competing with Chinese companies, we've always obviously had the issue of cost, but quality hasn't been a problem. We've always differentiated on quality. Now what they were finding was that in some cases, the Chinese products were actually of a higher quality than those made of Europe. And they were saying, we need to identify new ways of working with our customer and differentiating ourselves from our competitors. And here they've introduced things like sensing on bearings to measure things like speed, load, torque, vibration. And they're looking at ways they can introduce new services to take some of that predictivity or provide ownership of that predictivity to support their customers. So giving them early indication of potential failures or potential suboptimal performance. It also has an impact on the automation environment. Again, I'm not sure if many people come from this traditional automation environment, but this is a typical automation hierarchy or pyramid. You have the information from sensors being sent up to a control system, something like a PLC or a DCS. This goes through some different industrial or manufacturing software solutions, SCADA and MES systems, and ultimately up to your enterprise level solutions, something like enterprise resource planning. And it follows a fairly standard route of connectivity. Your devices connect through things like field bus and Ethernet, then they get sent up to a gateway which then communicates with the cloud. Now, with developments in sensing, but also in connectivity, we're seeing new communications protocols that are enabling companies to change the way they network their systems. And really offers the opportunity to de-stratify this typical automation hierarchy. No longer do you necessarily need to send sensor data straight up to a control system. Potentially this goes straight up to something like your manufacturing execution systems. And we've spoken with some sensor companies who have said the same. They say, we're looking to get business models through predictive analytics where we're not going to send this data through to the PLC where the controller companies can own this business. We're looking to send this data directly up to the cloud, partner with a cloud provider that does the analytics, and we will offer this service to our customers directly. So again, changing the way things are being done. This means different connectivity, but also different intelligence. We're talking about sensors with intelligence. We're talking about PLCs and gateways merging, so gateway functionality being put on PLCs in some cases, so that PLCs can now collect directly to the cloud. Again, a very different way of doing things. And even where the sensors are placed, more and more we're seeing sensors that are going to be embedded in product. Now, that's some differences in the technology, but there's also a very big difference in the supplier landscape. So if you've ever been to Hanover, you'll know traditionally that you have some of the big automation companies. Siemens will have a whole hall to themselves, a very large event, but then dominated by automation vendors. When the last couple of years we've seen a huge change in that with some really significant presences from the large IT vendors, whether it's a Microsoft or a Huawei or a Deutsche Telekom. These companies are really making their presence felt. And the key story really is that if you're looking to do Industry 4.0 or Internet of Things, this isn't something that one company does on its own. There's not a single company that has all of these expertise. So increasingly there's this need for creating an ecosystem of partners, having companies that can offer some of these different elements, whether it's on the OT side, the operator technology, it's the automation vendors or the machine builders that really have that vertical market expertise. They know what the pain points are in their particular industries or in the industries they sell to. Now that's something that companies in the IT industry, they don't have these expertise. You don't have IT companies that can understand some of the nuances in a packaging machine compared to a machine tool, or in the automotive industry compared to the food and beverage industry. So really this is an area where the OT companies are critical. But at the same time, they don't have expertise in creating IoT platforms or selling networking infrastructure or supporting cybersecurity solutions. So this partnership is really going to be key. And increasingly we see that companies that are being successful are companies that have developed an ecosystem of partners. But that's changing the landscape. More and more we're seeing IT companies having a bigger play. We're seeing a lot of investment in startups and acquisitions for companies to acquire additional expertise as well in these sides. Now, the introduction of these IT companies, it's a challenge both internally for an organization and externally in terms of who they deal with. So we asked some companies, when you're looking at IoT, internally, who's going to own that project? Is that an IT project? Is that an engineering team's project? Who's going to run that? And it was fairly evenly split. There's not a clear answer yet on who is going to run and own these projects. And certainly there are challenges. Getting an IT team and an OT team to work together are inherent challenges in terms of these organizations have typically been very siloed, worked very separately, very different perceptions around what to do with data, how to connect things. So it was fairly evenly split internally, but also when looking at who should lead a project. If I'm going to buy an IoT solution, who's my vendor? Am I going to work with an automation vendor? Am I going to work with a systems integrator? Or is it going to be my main IT supplier? And again, very differentiated. We do see some differences in terms of industry. So, for example, within the process industries, the oil and gas industry, the chemical industry, here people have a preference to work with their automation vendors, their systems integrators, just because of the centrality of things like the control system. When you look at some of the discrete industries, and particularly for the larger companies where they have very close partnerships with the IT vendors, this is where the IT suppliers tend to be more popular. But what are some of the benefits? So here's a nice long list of some of the applications, creating visibility across a factory floor, improving asset health, optimizing production. In the discrete industry, it's estimated that machinery utilization rates typically range in the region of 40 to 50%. That means that half of the time, products aren't being used. These highly expensive capital investments, these machines, are sitting idle on a factory floor. Now, sometimes that's because of downtime, but oftentimes it's because of either bottlenecks of production or inefficient designs. Now, as you introduce more of these new technologies, you increase your visualization of what's happening on the production floor. You understand where you can maximize your operational efficiencies. So this is one of the big areas that customers indicate was important to them. But also understanding asset health. So going back to the automotive industry, it's estimated that downtime on an automotive plant is about $20,000 to $30,000 per minute. Every minute production is down, you're losing a lot of money. This is a big concern. How do we eliminate or significantly reduce downtime? And here we're seeing a lot of solutions that are being introduced early on around Industry 4.0 are focused around asset health, whether that's condition monitoring, and condition monitoring is your asset flagging, hey, there's a fault, there's a problem, come and look at me, or whether you're taking that onto another level and you're looking at things like predictive maintenance, which is a product saying, hey, I'm about to fail and I've got about 3 weeks left to last, so you better send someone to me before I actually fail. And this is an important focus, like I say, for many companies. And traditionally, maintenance has been done in a very dumb method, if you like. There's not been intelligence feeding into that. You have reactive maintenance, something goes bang, you go and fix it. You have preventative maintenance. This is, I send someone around the factory floor every 6 months to check on all my assets. Maybe 80% of my assets are working fine, so that's inefficient use of my time. Maybe I'm going around and replacing certain assets because it's the end of their official life, and their lifetime is fine and they've got a long time to run. Now I'm, again, waste on my inventory. I'm replacing products that don't need to be replaced. Predictive analytics helps to better focus maintenance planning. You can target your maintenance staff and your workflows to focus on people, on assets that are about to fail, rather than a very ineffective way of maintaining facilities. And this is going to have a big change on our maintenance. We're going to have more efficient use. This will reduce the amount of hours needed for maintenance planning, for example. It will reduce downtime significantly as well. But the benefits go well beyond just asset health and predictive maintenance. It really does sit across the entire life cycle of a product. So from design, so Harley-Davidson as an example introduced some Internet of Things technologies partnering with Cisco. They were able to reduce their time to introduction of new products from over a year to a week and a half. Now, the ability to bring product to market faster obviously introduces a lot of competitive advantages, also significantly reduces your costs. In operations, there's a number of benefits in terms of reducing power consumption, reducing energy wastage. We were speaking with one company that is using it, an electronics manufacturer, that was using it for quality management. Traditionally, they had a 64-step process for producing some of their electronics, and they wouldn't be able to test the quality until it reached stage 32. Now, if you're identifying faults at stage 32, you've added new components. You've used heat for things like soldering. There's a lot of wastage, both in terms of energy, in components, and also in time. They introduced solutions that enabled them to monitor every step of the process. So from step 2 all the way through to step 64. And also they could do it product by product. So instead of monitoring one product on each batch, they were able to monitor every single product across every single stage of its production. Not only are you reducing things like waste, now you've got better visibility of the quality of your product. And they use this actually to help adjust their warranties on their products as well accordingly. I mentioned some of the examples on maintenance, some significant savings, 50% maintenance time reduced by CNH Industrial. But also it goes beyond that to inventory levels. You can reduce inventory levels here, reduce from 50% to 4% within 6 months. Again, big cost savings. Identifying bottlenecks. Now, and the companies are now evolving this, not just internally, but expanding that across their supply chain. Introducing solutions, especially within the electronics industry. We know that during the tsunamis, there was a big issue about how do we get processors to the right places? Do we have a visibility of when we're going to get our product to us? Now, having better visibility across your supply chain enables you to better support your customers. Now, I've said all of this, we talked about some technology, but where I really see the most significant change is in how solutions are offered to customers. And we're really seeing more of an outcome focus rather than, or a service-based or servitization focus rather than a product focus. If you look at a number of the large automation vendors, GE, Siemens, they've said, in the future, we will not be a hardware provider. We will be a supplier of software and services. That will be our focus. That will be our differentiation. We'll continue to offer product, but our business models will be based around servitization. Now, especially in the market, if you look at the machinery market, we're not talking about a market that is growing particularly fast at the moment. Obviously, China's investment in machinery production has decreased significantly. It's actually flat or slightly decreasing, we forecast this year. Now, this creates challenges. How do we generate new revenues? How do we continue to grow our business? But this also coincides with, as I mentioned, some of the challenges around a lack of engineering skills. Companies are increasingly being challenged with, do I have the engineering skills that can keep my facilities running? In the US, the UK, to a lesser degree Germany, companies are struggling with this dearth of manufacturing. And that has a net impact on total revenue. It's estimated that loss of engineering skills has about a 1 to 2% impact on total revenues, because you're training people up again, you're suffering the problems from downtime and things like that. Now, if you could move some of that maintenance, some of that service externally, create new service models where other companies are providing that service, that maintenance of your plant, replacement and repair. For many end users now, that's becoming increasingly attractive. But for vendors also, they're now seeing opportunities. We can develop new revenue models, not focused on product, but focused on offering a service. The aerospace industry is maybe one of the more famous for this. Rolls-Royce and GE also with their jet engines. In many cases now, they're selling what's called power by the hour. They're not selling product. They're not selling an engine. They're saying, we are selling you uptime. We will guarantee this product will continue to work. We will collect all of the data from our jet engines. We will do the analytics. We will do the repairs. And you just pay us an annual contract. You don't pay us for the product. You pay us a service contract. And this is being done across multiple industries. It's in the aerospace industry, within the transport industry. Michelin and Pirelli have started to introduce similar predictive analytics to understand wear of tires on fleets. So now you can predictively forecast when am I going to get a puncture. I don't need to have my truck sitting at the side of the road with expensive goods sitting on it, not getting to the customer when it needs to be there. They're also introducing things like energy management monitoring. So if I'm owner of a haulage company, I can actually monitor how efficient my drivers are driving and where energy is being wasted. And again, these are new services that are being offered to the market. I gave the examples of the motor industry. ABB is already starting to service its companies or its customers with some of these solutions as well. It does come with some challenges as well. We're talking about a shift from a CapEx model to an OpEx model. We're saying, okay, you no longer have to pay this high cost for a certain machine, for example, but you're going to pay a service figure. Great for small companies moving to an OpEx model. You don't have to have that large initial investment, but many companies are not set up to procure through an OpEx model. So there are going to be challenges in how products are sold. There's going to be challenges in even how internally customers are going to make these purchases as well, and that will require some change. There's also still a lot of questions around revenue share. If I'm selling a motor, how do I make sure I get my fair share of the revenue, rather than a big IT company coming along, offering some analytics and taking the majority of the revenue? So lots of questions are still out there about how revenues will be shared, what the revenues models will be. Is it profit share? Probably unlikely. Is it going to be sort of a fixed fee? Is it going to be some other sort of business model? So just as I close, and in summary, a few points. It's coming. Certainly many companies have set their business to Industry 4.0. But it's not happening tomorrow. And you could argue it's been happening for a decade already. This move to Industry 4.0 with connectivity, with sensing and collecting data, sending this data up to other systems, these are not new things. So it's happening. It's a slow transition. Probably the biggest challenge is people. People are slow to change. People are slow to become aware of how some of these technologies can impact their business. So IBM, when they first introduced their computer many years ago, I think it was Tom Watson, he said, the world will only ever have a need for 5 computers. Clearly he saw, okay, maybe this is a few applications where we can use this solution. With Industry 4.0, it's the same. Where will some of these analytic solutions, artificial intelligence, additive manufacturing take manufacturing? We don't know. There's still a lot of questions to be answered. There are things that will become widespread in the future that we haven't even thought of now that are going to filter into the market. But certainly, already there are technologies that companies are making the most of to improve their business. As I say, technology, it's an evolutionary process. The outcomes are really going to be where the change is. It's going to affect people. Workforces are going to need to change as well. If you're looking like I am, I'm looking at my future career for my kid, put them towards data science. There's a huge demand across multiple industries, the medical industry, the finance industry, and the manufacturing industry as well. People are going to need to increasingly become comfortable in how do I work with and how do I use data. And so training is going to be key within organizations. How do you train your workforce to enable them to use information and to be comfortable? So we worked with one company and they had introduced a solution in 2 facilities. 6 months down the road, one facility had already noticed significant benefits from the technology. The other facility, they'd canned it. The project had been closed because they didn't see the benefit, because they didn't have the training for their people. There was this reluctance to move to new technology and they didn't see the opportunity. So really what we would say is, as I say, it's happening. Get ready for it. Build it into your business model. Certainly many companies are. But like I say, it's something that needs to be considered in many companies' business models. And certainly it's starting, but we still have a lot of work with things like legacy systems, translating existing equipment on the market, on the factory floor, to being utilized. So that's all I have. I'll open it up now if there are any questions. Maybe a quick question. Oh, sorry, go ahead.
So, my name is...
Oh, sorry, do we have a microphone? Thanks.
Thank you. Hello, my name is Abhay Khandek. I'm from Bosch, Germany. I'm working in project purchasing. So as a mechanical engineer, so now in the future, as you said, there would be two types of engineers. One is IT engineers, and the rest would be the rest of them. So as a mechanical engineer, I'm working mainly with the mechanical components and different types of technologies related to the mechanical. But the thing that you mentioned, I'm not that much aware about, but in the future, most of the jobs will go in that direction. So my question is, how can I somehow keep myself informed so that I won't, let's say, have a job problem in the future?
How do we stop ourselves from becoming redundant?
Exactly, yeah.
So I think types of jobs are going to change. Certainly a lot of repetitive jobs, they're going to move away to robotics. As I mentioned earlier, the real challenge is becoming data cognizant. Companies don't want to fire all their work staff, so it's, how do we train our work staff to deal with this data? We're going to need more programmers. We're going to need people that can process this data, create visualization tools, develop applications that enable the work. So really it is more bringing some of those IT skills into that side of the business. But at the same time, some of the expertise you have is still very critical as a mechanical engineer, and you have the insight onto how some of these technologies can apply to your business that someone sitting on an IT level can't. So it really is about a fusion of OT and IT. It's not one or the other. It's fusing them together. But certainly, in terms of looking forward, I would certainly say it's training yourself around data science. Now, there's a number of organizations that are doing this. Companies are partnering with universities. Companies are introducing programs internally to create data science schemes with their work staff to enable them to do this. And we're seeing companies that have really benefited from this, where they found that some of their workers have been some of the best producers of applications as they've become more familiar with the technology. They've identified problems on the production line and been able to start influencing solutions that have helped them to really improve and optimize their manufacturing. Okay. Any other questions? Maybe a question from my side then. Who here would say they're doing IoT or starting to do IoT? Okay, so hopefully something that for the future we can take away. I mean, are people using any components of this? Robotics, 3D printing? We've seen some of these elements being used? Yeah? A couple of people. Okay. So as I said, I think that illustrates, we're still early days, and certainly myself and the industry will talk a lot about Industry 4.0 is happening now, and if you don't do it, you're left behind. There is a lot of education to be done. It's not something that we're going to revolutionize, despite what you might hear in the next 2 or 3 years. It's an ongoing process. Probably two-thirds of automation equipment isn't designed, that is on the field, the installed base of equipment isn't suitable for IoT solutions. So there's a lot of work still to be done. Okay. Well, thank you. If there's no other questions, thank you very much for your attendance.